Hi everyone. In today's challenge, we are going to solve this problem. The problem name is LRU Cache and the problem number is 146. Alright guys, so first of all, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. There we are going to see how we can solve this problem, what is the logic we are going to use to solve this problem. And after understanding the logic part, then we will move to the implementation part. And in the implementation part, we will implement our logic in Python and C++ programming language. In this video, we are not going to implement with Java and JavaScript just because the video length is going to be very long. But believe me guys, if you understood the logic and also seen the implementation of Python or C++, then you can easily implement in your programming language as well, right? And guys, if you want to have a look on the solution, which I'm going to write in this particular video for this problem, then you can go through the link. I will share the link in the description. There you can find the link of Python and C++ solution for this particular problem, right? Now guys, let's see what this problem say, right? So let's move all this thing and let's understand the problem statement. So problem says design a data structure that follows the constraint of least recently used LRU cache. So what we have to do in this problem, we need to design something that makes sense, right? So this is design level design problem, and in this we are going to design LRU, least recently used. I hope it makes sense, right? Now let's see, implement the class LRU cache, right? So we have to implement one class. The class name is LRU cache. So everything we need to do in this class only, right? LRU cache. Fine. Now this will have some function, right? So first is nothing but we can say constructor. You can see first constructor that will take only one parameter capacity, and it will initialize the LRU cache with a positive size capacity. So with this meaning, you can see guys, capacity is nothing but always going to be positive, right? So we can say whatever the value we are given with this constructor, that is going to be the capacity of our cache, right? LRU cache size. Fine. The second is nothing but going to be one function, that is get, which will take one parameter key, and this will nothing but help us to return the value which is present with respect to that key, right? If key is present in our LRU cache, then we are going to return the value with respect to that key. Otherwise, we are going to return -1. I hope it makes sense. Either you have to return value, either you have to return -1. The third is function is nothing but we can say put function. This will take two parameter, key and value, right? So what it's going to do? First of all, it's going to check if key is present. So we have to update the value of that particular key with this given value, right? But if key is not present, so we have to insert a new key with this particular value. I hope it makes sense. And the third condition is nothing but if that capacity of our cache is getting more than the given capacity after inserting this particular key, then we are gonna remove the least recently used. You can see this line. If the number of keys exceed the capacity from this operation, evict the least recently used key, right? I hope it makes sense, right? So these are the three functions easily understood, right? So now see the next line, that is function get and put must each run in big of an average time complexity. Now we have to make a logic such that our we can say cost, or we can say the time complexity of get function and put function should be big of 1. It should not be big of log of n and anything, but it should be big of 1 with average time complexity, right? Okay, so now let's see the example, and let's try to understand this problem statement with example. So guys, we have this first example. There's only one example. So there the capacity they have given it 2, right? So we can say our cache capacity is going to be always going to be 2. So I'm going to say capacity is 2, right? Now let's see next line. They have put 1 with the value 1, right? So on key 1 they have put 1. Second is they have put on key 2 they have put 2. Third is they are going to get 1. So they are asking what is the value at key 1. So there is one value, right? So we are going to return nothing but answer 1. You can see we have written 1. Then they are putting a 3 with the value 3, right, on a key 3. So let's say I put 3, but this is wrong, right? Because capacity is 2 and we are inserting a 3 size. Now this is let me show you different color. This is 1, this is 2, and this is 3, but we can insert only 2 because the capacity is 2, right? So we can't do this thing. So what we need to do, we need to remove the least recently used, right? So what I'm going to say, I'm going to say fine, I'm going to remove which is least recently used. Now guys, you have to tell me which is least recently used, because you will say one is the least recently used because it is coming earlier. No guys, the 2 is the least recently used because we have, you can see we have used a get function here which is taking this particular value, which is using this particular value, right? So I use a get function with a key 1 before that. So like this, get 1. So this is returning a value 1. So this means this has used one time, but this hasn't used yet. So this is used 0 time, this is used one time. So least recently used is nothing but 2. So we are going to remove this one and we are going to insert now 3 here. All right, now it's going to say both have now 0 0, right? It's not now, it has a 1 use time because it is coming after this, right? Okay, now put, we have to put nothing but 4 comma 4. Again we have to put, no, before that we have to get. What we have to get, we have to get at key value 2. So guys, what is that to 2? there is no key present with the 2 value, right? In this you can see this cache, there is no key present with the value 2, right? So we are going to say there is no, so we are going to return nothing but -1. You can see in the output as well -1, right? Now it is going to put what 4,4. So we are going to put 4,4, but again we can't do this because the size is going to be 3 now, but we cannot exceed more than 2. So what we are going to, so we are going to remove the least recently used. So here least recently used is nothing but 1,1, and you will say why, because it has used one time but 3 has used 0 time. No, but 3 has come later, right? So this has come later, but this was earlier and after, before earlier as well. This is like this one case, even if it is earlier, but still it has been used before this. And how can I express this? Like after inserting a 3, did you use a 1? Just think about this, guys. After inserting a 3 value, or after inserting a 3 key, did you use a 1? No, you haven't used it 1, right? So that means the latest use is nothing but 3 only, right? So we are going to say 1 is come as a least recent use. So we are going to remove this and we are going to set 4,4. Fine. Then I'm trying to get a 1 value, right? So 1 is not present in our dictionary. So we are going to return -1. You can see again a -1. Then we are going to return 3 because it's asking for 3. Then it's asking for 4. Then we are going to return 4. So I hope guys it easily understandable, right? I hope you understood this particular example, and it's might be a little complex, but believe me guys, if you go through this again, or if you type by yourself after understanding this particular because example, then you can easily understand, completely understand this example, right? So try to we can say solve by yourself as well this example. It is the easy one, right? Just we need to keep check which is the least recently used, and this is very interesting logic to we can say maintain this particular thing as well. How to get a least recently used in just big of one. So don't worry about that. We are going to see that particular part later as well. But for now, you just need to understand the problem statement, right? I hope you understood this. Let me summarize this. The first thing is nothing but we are given one class LRU cache. The second is nothing but we are given some constructor over there, which you will have one parameter capacity, which is total capacity of our cache. Third is nothing but we can say get function. Get function is going to return the value which is present at that particular key. If that key is not present in our cache, so we are going to return a -1. The fourth function is not fourth function. The fourth point is nothing but we are given one more function, that is put function, which is going to insert a value with respect to that key, right? And if the capacity size is getting more than the given capacity, cache size is getting more than the given capacity, so what we are going to do, we are going to remove the least recently used element, right? And we are going to set our put element, right? So that's all we are going to do in this part. So let's see how we can do this, right? So let's move to the logic part. I know I'm going a little fast here because guys, if I'll go in a slow pace, then you guys will see the video length is going to be more than 30 minutes, right? And I don't want to do that because most of the people find it really, we can say, the long video, so they don't overthink think to play this one, right? So I'm going to say one condition here. I'm going to say logic part here, fine. And here what I'm going to do, I'm going to say, all right, so logic. So what we are going to do here, first of all guys, we are going to say I want to maintain the least recently used. I want to maintain least recently used element, right? Second thing, I will say I want to delete in big of one, and this is also maintained in big of one only, right? And third one is I want to insert in big of one. So I want to do these three things, right? I have this challenge, right? So maintaining a list recently used, deleting a big of one, inserting in a big of one. So how can we do this? We can do this by using a simple linked list, right? Because linked list also we can't do, we can do only by using a doubly linked list, right? So we are going to use a doubly linked list here, and how this is going to help is, let's see. So guys, let's understand from the first example only. So I'm going to remove all these things and let's see with the example one only. And here you will find it very easy with the doubly linked list, right? So I'm going to default. I'm going to select some default. We can say dummy nodes. The first node is going to be dummy node -1. Second node is going to be dummy node -2, right? So let's write -1 here also. These two are dummy node, and this is a doubly linked list, right? Fine. Now we go to one element. It says that put 1,1. All right. So we are going to put it. Don't worry about this one. We can easily put it, right? So I'm going to say fine, remove this one, and I'm going to say put 1,1, right? So this is going to be one value as a one key, right? And after that there is our dummy node, right? I want to say nothing but this is our dummy node -1 and -1, right? So this is nothing but will always going to be present on the left extreme left side. This is always going to present at the extreme right side. Right, now it's asking to put 2,2 as well. So let's quickly do this all these things in a quickly. So I'm going to say 2,2, right? And here -1. This is nothing but we can say right side. Fine. Then it asking us to get the value at key 1, right? So what is the present at key 1? So you can see that this is present at the key 1. But how, you will say now how we can reach to this one? So we are maintaining one hash as well. which will be stored in this particular node. So on key 1 this node is present, and on key 2 this node is present, right? This is nothing but a hash, right? So from this key we can directly reach to this node and we are returning that particular value. That makes sense, right? Second thing, once we got this value, as we are using it, so we are going to remove this from here, and I will say remove this from here, and we can say just shift here by one value. So we have shift here. Now as we have removed from there, so what we are going to do, once after removing, we are going to insert it at the least side, right side, right? So I'm going to insert it over here. I hope it makes sense now, guys, because we have used one, so it should come at the right side, right? Fine. Now we are going to say again, we are going to say put 3 comma 3. Now we are going to insert 3 comma 3. But as we know that the size is already full, you can see this capacity size is 2, it's full. So what we are going to do, we are going to say fine, we have to remove the least recently used now. So which is going to be least recently used? This is going to be this one, because the least recently used always present on the left side. We are maintaining the LRU on the left side. So always least recently used completed at the left side. So we can say we can easily to the reach to this one by big of 1, and we can remove this one, right? So if I remove this one, I'm going to shift all this thing over here. This is going to be 1 now, and this is going to be minus 1, right? And this is nothing but right. But we have to insert now 3 comma 3. So I'm going to say remove this one and insert 3 comma 3, because the latest will come on the right side, and here it's going to be minus 1. I know it's not, image is not clear to you, but try to understand from this only. I can't draw a better like, so try to understand from there only, right? So this is not at the right side. So we are maintaining a LRU at we can say in just big of 1, and we are also getting whether the node is present or not in big of 1, and also we are removing in big of 1 only, right? Now you can see how we can do this, right? So we can say now it's asking for get added 2. So 2 is not present in our dictionary because this is now 3 comma 3. So 2 is not present, so we are going to return minus 1. Fine. Now it's saying that put 4 comma 4. Now we have to put, but which is least recently used? 1 is least recently used, right? So we are going to say fine, you have to remove this one, and 3 will come here and 4 will come here now, and this is going to look like this. Now you can see 1 is not present because 4 is now this 1 has been removed, so 1 is going to remove from dictionary, and 4 is going to come from that place. Now we are going to say 1 is not present, so return minus 1, and it's asking for 3, then 3 is present, so we'll reach to this particular node, and we are going to return this value 3. Then 4 is present, so we will reach to this particular node and we'll return 4. That simple thing, guys. We are just maintaining a doubly linked list. We are saying that least recently used will always be on the left side, and which is used the most time, or we can say which is totally opposite to the least recently used. So we can say that is going to come at the right side. Means every time whenever we are performing insert operation, means put operation or get operation, we are putting that element to the right side, right? Even if that particular element already exists, if we are updating that value, then still we need to remove from that particular position, we have to insert on the right side. This will help us to know which is the least recently used element, right? After that we can easily remove from the w linked list in big of 1, right? If we want to remove 4, so what we need to do, we can reach from dictionary from 4 key to this particular node, we can reach in big of 1. After that I can say just take this left element which is 3 and take this right element which is minus 1, and say 3 of next is minus 1 and 1 of previous is 3. So this automatically this we can say node will gonna remove in big of 1, right? I hope it makes sense, right? Still you are not getting, don't worry, let's move to the Python implementation and C++ implementation. There you will easily understand how we are going to do this all, right? So I'm first of all with Python, guys, and here what we are going to do, we are going to first of all maintain a doubly linked list class, right? So what I'm going to say, I'm going to say let's create a class, and the name I'm going to give a list node, because I used to do this, and here I'm going to say define init. Let me just do this self, and here I'm going to say key comma value, right? This is going to be constructor for my key. Fine. And here I'm going to say self dot key should be equal to key, self dot value should be equal to value, self dot left, not left, you can say next is going to be nothing but none initially, self dot previous is going to be none initially, right? So this is our doubly linked list, no, right? Once this is done, then we are going to come to our main class LRU cache. Here we are going to say self dot capacity is going to be nothing but capacity, and after that we are going to maintain two left and right side, right? Left node and right node, extreme left and extreme left. So left dot self dot left is going to be nothing but always list node of -1 and -1, -1 and -1, and self dot right is always going to be list node -1 and -1, right? But by this we are not making a doubly linked list. We have to say left self dot left of next node. This operation we have to say next should be self dot right, and self dot right, let me write a self dot right of previous should be equal to self dot left, right? Now it's going to say this is a doubly linked list, right? So once we got a doubly linked list, then we have to maintain one dictionary as well. As I have told you, self dot dictionary is going to be initially empty. So in the get operation, first of all, we are going to check if key is present in our self.dictionary, then we have to say fine, it is present, right? So then what we are going to do, we are going to say fine if it is present. So remove first of all from that position and insert at the right side so that we can maintain least recently used. So we can say remove self.remove this dictionary of, we can say key, and we can self.insert this dictionary of key. Don't worry guys, these are not inbuilt function. We are going to make these two functions, remove and insert. But what this function will do, this function will remove that particular node from that particular position, and insert will insert that particular node at the right position, extremely right position, right? After that, what we are going to do, we are going to say return self dictionary of this key. Then what we are going to do, we are going to say we have to return this value, right? And after that we can say if it is not the case, means this condition will not work, right? If key is not present in this range, so we are going to directly return -1, right? After this, we are going to come to the our put function. Their input function, we are going to say we have to insert the data at that particular key, right? We have to insert this value in this key, right? First of all, we need to check if key is present in our self.dictionary or not. If it is present, then what we are going to do, we are going to say not remove this particular dictionary of key, right? And I'm using here dictionary, but it is not accessible. We have to use self keyword, right? And here also I have to say self.dictionary. Remove this self.dictionary, right? So once we remove this data from that particular position, if it is present, right, then only we are going to update it, right? Now we are going to insert on the right side. If it is not present, so we don't need to remove it. We can easily insert on the right side. So we are going to say insert. First of all, let's say dictionary of key is going to be nothing but, okay, what we are going to give, we are going to give say list node, and the key is going to be this, and value is going to be nothing but this one. Fine. And after say, we can say insert this dictionary of key, right? So this will insert at the right side, and we have also put in our hash map. Once this is done, then we are going to say if our self dot, we can say length of self dot dictionary, if length is greater than the given capacity, self dot capacity, right? Then what we are going to do, we are going to say if it is greater than capacity, then we have to remove the least recently used, right? So how we come to know that? We can get to know this particular node in just big of one, that is like this LRU, least recently used, or we can say the given node, right? So we can say okay, LRU is fine. LRU is nothing but we can say okay, self dot left dot next. So this is always going to be our least recently used, right? Fine. And now what we are going to do, we are going to say fine if it is the case, then you have to remove this one, remove LRU. And after that, what you are going to do, you are going to say if you have removed this one, so what we can do, we can say once we have removed this one, we have to remove this particular key as well, right? So we can say del means nothing but delete self dot dictionary of this particular LRU of, we can say key, right? That's why we are maintaining this particular key. Why I'm maintaining this key? Just because to delete once we got that particular we can say exceed of our cache size, right? So now once we done this particular part, then we are going to make two function, that is nothing but insert, define insert, that is going to take a node, and we are going to say we are going to insert right. This node we are want to insert on the right side. So what is the top right extreme right node? That is nothing but right, self dot right. So we are going to say the right, or we can say let's give it a name previous. First of all, let's take a previous and the next node, right? Previous node and the next node. So previous node is going to be nothing but self dot right dot previous, and next node is going to be nothing but self dot right. And let me show you this with this particular thing. So guys, let me just take this one and see. I have this node 1, I have this node 2, I have this node 3. So right, I have this thing, right? And this is nothing but our -1, and this is nothing but our -1. Right? I want to insert now 4, and I want to set it on the right side, right? Because that's how we are maintaining a list instantly, right? So I want to set 4 at the right side. So I'll do, I'll say I have a right variable here which is pointing to this one. So I will say just give me their previous node which is 3, and just give me the this node, this is next node, means current node, this is -1. So I will say now I have two node now. I will say its next should be over this 4, and 4 next should be this one, and 4 previous should be 3, which is a previous node, and 4 next should be -1. So this is how I can insert a 4 in between of 3 and -1, right? So I'm just doing the same thing. The next node is going to be self dot right, and previous node is going to be self dot right dot previous. Now I'm going to say previous node of next should be equal to which node? Our current node, and node dot, we can say previous, it should be equal to previous node. Right. So this is how I maintain a two thing now. This is how what I have done. I have just done this much part. Let me show you. I have done this much part now. Right. So 3 is now having a next node to 4, and 4 is having previous node to 3. But I have to also say node dot next, which should be our next node, and node dot next node dot previous should be pointing to our node. So now by this I have inserted these two line as well. I am saying 4 next to this, and 1 -1 next is previous is 4. right? Once this is done, then what we are going to do, we are going to say come out from this function. Now come go to remove function. This is going to have self keyword, and this is going to have node keyword. Node keyword node this node value, right? So now I want to remove this node, and how can I remove this node? Let's see. So I'm going to say, let's say I want to remove one of these two, right? So I'm having this two node. So what I'll do, I will say just take a previous and take a next, and after that, once you take a previous and next, just assign this two, right? One now one next was two, but one next now will be three, and now we can say one, we can say this three previous was two, but three previous will gonna be nothing but one, right? Simple thing here we are going to do, we are going to say next node and previous node. So we can say like previous node and next node is going to be nothing but self dot node self, we can say node dot previous and node dot next. And now I'm going to say previous node of next, we can say next should be equal to next node, and next node dot previous should be equal to our previous node, right? I hope it makes sense, right? So once this is done, then we are going to do nothing, right? After that we can say let's run this code and see whether it's working fine or not. So I believe guys it should work, right? Let's see that part as well. But no, it's working wrong because we haven't used a self keyword, and here also we haven't used a self keyword. Now let's see, right? Do we have any more error? I don't think so, right? It should pass. But no, insert is again saying insert. Okay, I can't access this, right? I have to use self dot insert, right? And I have to use self dot remove. And let's see now. Okay, you can see guys that test case is accepted. So let's try to submit this code as well, and let's see whether it's getting passed or no. And I believe guys it also gonna pass it, but remove is not defined. What the hell? Let's see now, right? Now let's try to submit this code. Alright, so I believe it should pass now, right? You can see guys it successfully got submitted, right? So we have submitted with Python. Now let's move to the C++ quickly, and there also we are going to do the same thing. We are going to maintain first class, so we are going to make a class with the name list. Not with this node, because this is already defined, right? So we are going to make a class with double node. Alright, so this double node class will have one public first of all, and we are going to make a constructor double node, and this constructor will going to have two value int key int value, and we are going to say this dot key should be equal to key, this dot value should be equal to value, right? And here we are going to find two things, int key int value, let me just say value, right? And here we're going to say also this node, and we can say next isn't going to be, and one more thing, this node previous, right? So when this is done, let me give a value name is only, right? Value does not make sense, right? And here we are going to say previous should be equal to now null ptr, and next should also be null ptr, and here also I can say value. Fine, so I have defined a class with a double node name, right? And here in this class, main class, we are going to say int capacity. In capacity we are going to say this capacity should be equal to capacity, right? Capacity. Fine, so once this is done, then we are going to say make a new we can say map dictionary. That means we are going to say unorder map. Here we're going to say int, here we're going to say double node, and here we're going to say find, and the name I'm going to give dictionary only. And here after that we are going to find two more things, that is nothing but double node star, and here we're going to say asterisk. We can use here we're going to say left, which is going to be nothing but we are not going to define here, we are going to just say double node, and we're going to say find, and this is going to be right. So in this constructor we are going to say left should be equal to now new double node, and here we're going to say pass -1 as -1 by default. And right should be equal to new double node, that means a double node, and here we're going to pass -1 as a -1, right? So this is nothing we can say we have defined extreme left and extreme right dummy node. And also we can say find, if this is done, we are going to say left of next should be pointing to right, and right of previous should be pointing to next left, right? So by this we have created a doubly linked list, and default we have defined two dummy node as well on the left and right side, right? Now once this is done, then we are going to come to get function. Here we are going to check if our dictionary dot find this key is not equal to dictionary dot end, that means key is present. So if key is present, then we are going to first of all remove that node, then we are going to set on the right side, then we are going to return that particular value. So I'm going to say self dot not self is not going to work here. We are going to say simply remove what you have to remove. You have to remove dictionary. Let me just say dictionary of key, which is going to be obviously node, right? And after that you have to insert dictionary of same key. Once this is done, then you are going to return dictionary of key and you are going to return that value. Fine. If it is not present, then you are going to say return directly -1. Now we are going to come to the next function, that is the put function. Here we are going to say if our key, if this, let me just say, if dictionary dot find this key is not equal to dictionary of n, right? If it is not the case, then we are going to say what? We are going to say nothing but that means that particular key is present in our dictionary, so we are going to update that value. So for that, first of all, we have to remove this node, because then only we can update it. We are going to move to the right side. So dictionary of key, you have to remove this particular node. Once you are done with this thing, then we are going to say nothing but we are going to say dictionary of this key, insert a new node. Right now we are going to update it, so that's going to be nothing but a new double node. Right here we are going to say find the value is going to be value and key is going to be key. Fine, once we have inserted in our hash map in dictionary map, then what we are going to do, we are going to say fine, we are going to insert it on the right side, insert dictionary of key on the right side. Once you are inserted on the right side as well, then check if our dictionary dot size is greater than our capacity. If it is greater than our capacity, then what we are going to do, we are going to say fine, we have to remove the least set use, so we can say double no. Our least set use is going to be what we can say left of next. And once this is done, then what we are going to do, we are going to say if it is the case, then remove this one, remove LRU. And once you have removed this list and use, then you're going to say okay, we have to remove that particular thing from the dictionary as well. We have to remove this because a key, so we can say dictionary of erase. You have to erase this particular key. What is key? So that is nothing but LRU of key. Also, once this is done, we are going to define two more functions. That is nothing but we can say first function is remove. Find this function is going to take nothing but a double node of we can say node, and here we are going to take, if we want to remove it, so what we are going to do, we are going to say first of all take a left side and right side of that particular node and just join that two particular node, right? I mean by this only, if you want to remove a 2, then you have to take 1 and 3 and you can make first 1 next is 3 and 3 previous is 1. So I'm going to say double node, and here I'm going to say the next which is going to be previous node, right? Previous node is going to be nothing but equal to node of left, or we can say previous, and double node same thing. I'm going to say next node is going to be nothing but a node of next, and here I'm going to say previous node of next is going to be nothing but we can say next node, and next node is of previous is not going to be nothing but we can say previous node, right? I hope it makes sense. So once this is done, we are going to remove this particular node. After that, I have to make one more function, that is nothing but insert. This is going to take again a one node only, double node and node. We have to insert this node at the right side, extreme right side. So we are going to say double node, and we are going to take first of all previous node, which is going to be nothing but right of previous, and one more double node, and I'm going to give a name here as a next node, which is going to be in itself a right. Fine. Now I'm going to say previous node of left side of left, no, not left of next is going to be over this new node, and this node of previous is going to be over this previous node. So we have make a one side relation. Now we are going to say node of next is going to be nothing but this next node, and next node of previous should be over node, right? So we have make a second relation, second type of relation, right? Let me show you. So first we have make 3 to 4 relation, then we have make 4 to -1 relation, right? After that, but once this done, we are gonna check our code whether it's working fine or not, right? So let's see. All right. So it's taking a time, but it's give an error because right is not exist. Left of next is right. RIGST, right? So it exists, right? So it's saying that compatible pointer type to list node to the all right. So list node, where we have mentioned list node, right? We have done somewhere a mistake. Should not be the list. All right. So here we have done list node. I don't know what's happened to me. This should be double node, right? Let's see somewhere else I have done this node because I have used in Python. So it's keep having. Let's check. No guys, you can see it's all the pass, right? So you can see only one test case was there and it got passed. So that means we have successfully submitted with C++ by just clicking this button. Now you can see it successfully got. It's taking a time. Why? You can see guys, it successfully got submitted. Finally, it's got submitted. So we have successfully submitted with Python and C++, and you can see guys the video length is going to be very long. So I hope guys you can easily implement in Java or JavaScript or Ruby, any other programming language which you are using. But believe me guys, if you understood the logic part and the this implementation part, you can easily implement in any programming language, right? And I believe guys you have understood the logic part, problem understanding part, and the implementation part. If you have any kind of doubt in these three we can say section, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.